Hello to the respected staff and teachers. This is Karthik and this is my team Gautam, Karan and Karthikesan. We have done a project based on the theme Embedded Systems in a simulation software called Proteus 8 Professional. The name of our project is Distance Meter using an ultrasonic sensor. So the basic question which arises is that what is a distance meter? It is an ultrasonic sensor based distance meter which enables us to measure distance of a target object without making any kind of physical contact whatsoever. It helps to measure distance in places where it is almost impractical to measure distance physically. Therefore, the basic components that are required for this distance meter design are Arduino Uno board, an HCSR04 ultrasonic sensor, and a LED display. Now we're going to see about the basic components with a little more detail. The first component that we have is a 4-pin module HCSR04 ultrasonic sensor. Its operating voltage is plus 5 volts and it's capable of transmitting and receiving ultrasonic waves. As we can see from the video, it has a predefined X file which is dumped onto the ultrasonic sensor for the process of measuring the distance. The next component that we have is Arduino Uno, which is an open source microcontroller board based on the microchip AT-MEGA328P microcontroller with 20 pins. The coded program is dumped onto the Arduino board, and additionally a DC motor and a light emitting diode is connected to the Arduino for the proper functioning of the distance meter. And the last basic component is a liquid crystal display which displays a measured distance in terms of inches and meters. Now we are ready for the simulation, but there's one thing that we have to take care of first. We can't physically change the distance in Proteus simulation, and so we use a variable resistance. So when we vary the variable distance, the distance varies. By doing that, we can change the distance and find its approximate values. We have coded in such a way that whenever the distance is less than 20 inches, the motor and the LED will be turned on, and whenever the distance is greater than 20 inches, it will be turned off. Now we're going to start the simulation. At first, the ultrasonic sensor transmits ultrasonic waves, and when these waves are transmitted, parallelly the counter is also started by the microcontroller in the Arduino board, and when these transmitted waves hit any obstacle, it is reflected back to the sensor. And when the reflected waves are received at the ultrasonic sensor, the microcontroller stops the counter and measures the total duration of the wave travel. Using the speed of light and total time taken, the microcontroller determines the distance of the obstacle from the ultrasonic sensor. Then the measured distance is displayed on an LCD in terms of inches and meters. And as you can see from the video, if the distance is less than 20 inches, the motor and the LED would be turned on, and if the distance is greater than 20 inches, the motor and the LED would be turned off. This is the basic working of the distance meter using an ultrasonic sensor, and that's it for our project. The other applications of this distance meter is that it also can be used as a security sensor, can be used to measuring liquid level in a water tank or in a fuel tank, and so many other applications. And last but not the least, we would also like to thank you for sharing this opportunity. It's been a pleasure. Thank you.